Hello and welcome back to Kentucky Home Garage. Today I want to talk about relays. If you have an electrical circuit involved the relay and your suspect is the relay, you can simply swap the relay with a known good one, put it in place, and if you fix the problem, it's great. Now, what if you don't? What if you put new relay in there and you didn't fix it? Now we have to do all the checks on the relay voltages and to figure out, what the problem we have. Relays are can be sometimes a little bit confusing because they involve two different electrical circuits. We have a control side and the load side. Essentially how it works, the control side of the relay has an electrical winding, and when the current is flowing through that electrical coil, basically it will create a magnetic field, and this magnetic field is going to there's a on the load side of the relay we have a switch. This switch is going to close and it's going to give the power to our load. Now this schematic is from a fuel pump from my 2005 Chrysler Sebring. And what we have here, it's the fuel pump. It's constantly grounded. It's connected to our relay. We have on our load side of the relay, we have a fuse number 8 that's hot all the time. And on the control side of the relay, we have a fuse 23 that is hot in run or start. And then our PCM will give the ground to our coil, and this tells us that this is a ground size switched relay, and once the PCM energizes the relay, the switch is going to close and it's going to give the power to the fuel pump, and the fuel pump is going to run. So when a PCM energizes the relay, we're going to hear that click, and that's when this mechanical switch will close, and it will give the power to the fuel pump. So now the most challenging part of this testing is, and for me anyway, is how to get access down to pins that we need to test on our relay, because the relay is sitting in a fuse box and it's completely covered. There's nothing we cannot get underneath to check the voltage. So I was watching the video, the Real Fix Real Fast with Dwayne. He's an awesome guy. If you guys want to learn electrical troubleshooting and any other problems with the car, he's number one. He and Skinner Daner and the South Main Auto, and these guys are awesome. But when I watched the video on Dwayne made actually a relay, he took a single wire, copper wire, and he wrapped it around each of these legs and and got those wires up on the relay, so you could actually do your test. You checked your voltages, and it works great. I mean, but one problem that I did, because he knows what he's looking for. For him, it was easy, but for me, it was still confusing because I didn't know what part of the relay am I testing. Is it a control side of the load side of the relay? So what I did, I made a relay. So to do this, you're going to have it known. You're going to find a good relay, of course. And again, this test is not going to test the relay. This test will be done after you swap your relays, and that did not fix your problem. Now you have to go into the fuse box and figure out what the deal is. So what I did here, I made this relay, and I had four wires. Got red and black and blue and green wire. Now I had all four different colors for the reason, and I just picked these colors because these are wires that I had in my garage. And the gauge, I really don't know, but the smaller the better. This is some kind of control. It was actually from my broken, I think it was a dishwasher or something. There's some kind of control wires. But anyway, so what I did, the relay has 4 pins on it. It has a pin 86, and 85, that's the control side of the relay, and the pin 87 and 30, that's the load side of the relay. So I soldered these wires. You guys can see that. The red one is on pin 86, the black one is on pin 85, the blue one is on pin 87, and the blue one is on 87, and the green one is on pin 30. Okay, so now when I do my checks on my relay, now I can easily access my fuse box basically and do all the checks. So now I'm going to show you guys, how easy it is to actually recognize all the pins and the voltage and what we need to see as we go along. So now I'm going to get my camera down to my fuse box, and I have my voltmeter. Sorry about that. Alright, so now here is my relay for my fuel pump. I'm going to pull it out, and I'm going to put my relay in there. I'm going to get some more lights. I'm afraid it's not going to show all the... Sorry about that. Okay. All right. I hope you guys can. I'm not sure if you guys can see the my wires. Let me zoom this a little bit. Make sure you guys can see my my relays. Okay, I hope the camera is going to show. I think it will. Okay, so now when we look our diagram, we can go ahead and check our load side of the relay. Is easy one. We can just take the voltmeter and check one of these pins here. One should have 12 volts, and once we find the one with the 12 volts, that I know I'm at the fuse number 8. So I'm going to have my voltmeter. I'm going to have my black lead on the ground, and my red lead. I'm going to touch one of these two wires on my load side, the green or blue one, and see what kind of read I'm going to have. So I got a 0 volts here, and I have a 12.5 volts, so that's my battery voltage. So I know this is my fuse number 8 right in here. So that fuse is good, so I'm just gonna, so we are measuring 12 volts right at the fuse, and this is my blue wire. Okay, now wait a minute, I'm sorry guys, this is my green, I apologize. So this is my green wire, and that will be my pin number 30. Okay, so it's going to be pin 30, my green wire. Okay, so now I'm going to address my pin number. Now I know that the 87 is gonna be the blue wire. Okay, so this is my pin 87, and the way I'm gonna test this circuit, since this circuit is open right now, I'm gonna take a test light. I'm gonna connect to the battery positive, and if this circuit is intact all the way through the fuel pump to the ground, my test light is gonna light. Okay, so let's check that real quick. So now I'm going to take my test light, I'm going to connect it to battery positive, and I'm going to touch my blue wire, and you can see my my test lights. Okay. All right. So now I know that my fuse is okay, and my circuit is intact all the way through the fuel pump to the ground. Now, what are the possible problems if we check the green, then pin number 30, and we do not see 12 volts? Okay, so one of the options, one of the possible problems could be a blown fuse. Okay, so basically we have an open here. We could have an open between the fuse and the relay in this wire, and because this is all inside the fuse box, then we will have to replace the fuse box. Other problem, an issue with since we have a blown fuse, the fuse can blow. If this fuse feeds some other loads, we need to check our wiring diagram to see if this fuse gives power to any other loads, and if it does, we have to check those for shorts, make sure they are not shorted. Now, other possible here is that this wire on the fuel pump side is shorted to ground and blows the fuse. And then one more would be a possibility where we have a bad fuel pump that draws too much current, and it blows the fuse. So we need to check the current on our fuel pump. Now, if I would connect when I connect my test light and I connect it to battery positive and test light does not light, and that simply tells me that somewhere along the line I have an open in my wiring from the fuse all to the pump down to the ground. Maybe I'm having bad commutators on my fuel pump, or I have an open somewhere, or bad ground. So basically, what this gonna give me, this gives me quick directions, what to check, which way to go. So that's how we address the load side of the circuit. Now we're going to go to control side of the circuit. Now on this side, what I'm going to do, I'm going to turn the key on, and we can simply just take the voltmeter, okay, and connect one lead on the black wire and one on the red wire, and when I turn my key on, or in some cases I have to crank it to get the fuel pump to run, to computer to activate the relay. And if I read 12 volts here, I know right away that I have a good fuse and I have a good control from the PCM. It's that easy. So let's do that real quick. So now I took care of my load side of the circuit. And now I'm going to connect my leads from my voltmeter to black and red wire, and then I'm going to turn the key on. And if I see 12 volts, then I know that I have a good fuse and I have a control from my PCM. Okay. See it? Okay, good. Now, so I'm just going to turn the key on, and I'm sorry. Why is it turning it off? That doesn't make any sense. Sorry guys, I'm trying to turn the lights. I think my battery is actually low on this. When I turn my light on, it shuts off. I think it's the battery issue. So anyway, I'm gonna turn my key on, and my computer should energize my relay to turn my fuel pump for 3 or 4 seconds. Okay, so you guys could see I had a battery voltage there. This tells me that I have a good fuse, number 23, and I have a control from the PCM. Now, what could be if, for instance, I turn my key on and I have 0 volts. Well, one of the possible scenarios would be, of course, blown fuse. Let's just, I'm going to take this fuse 23 out. And I'm going to do the same. I'm going to turn the key on and off, cycle the key, and now we can see we have 0 volts. Okay, so now how are we gonna so now we have 0 volts, and at this point actually we don't know. I mean, I pulled the fuse out, but next check would be to check each of these pins, red or black, for the battery voltage, to check for my fuse number 23. And simply I would just unplug one of these, let's see, unplug it. I'm going to leave one connected. I'm going to check once I got 0 volts, and I test it again, and I have 0 volts again. Now this gives me information that I have a problem with my fuse. Now that I would check fuse number 23. If my fuse is blown, I will replace the fuse. Of course, I have to check if this fuse is gives power to some other loads to make sure I have a short. One other, now if I have a good, also I forgot on this side, if I have a blown fuse, I also could have something shorted out inside my inside the fuse box as well. So if my fuse is blown here, I can have a short inside my fuse box. I can possibly have a that's not really so I can have a short inside the fuse box. Now if my fuse is okay, but I don't getting power to my fuse, then I'm gonna trace down to my ignition switch to see if my ignition switch is okay. That's supposed to give the power to this fuse. So it's just it's really easy as that. So and now also we can so at this point we know that we have a, well, let's just check the let's put the fuse back in now. So now when we check, let's see what I'm doing here. Well, I put my fuse back in there, and I'm checking one side now. Let's see, did I put the fuse back? Yeah, actually, I need to turn my key on. So I'm reading 12 volts here, and I'm going to read 12 volts on the red and black wire. I'm going to read 12 volts, and the reason I'm reading 12 volts right now is because I don't have a current flow. So I got a good fuse, and my voltage is going to be 12 volts here and 12 volts here as well, because I don't have a current flow. I don't have a voltage drop. So once my PCM gives the ground, then I'm going to have 0 volts or maybe 500 millivolts or something like that on this side of the circuit, and I'm still going to have 12 volts on this side. Now we need to one other thing we need to do, we need to identify which is a this is a little hard now, because which pin is fuse and which pin is my control. And the way I'm going to do that, I made another fuse, another relay right here, and I just put the red and black wire on my control side of the relay. So, but what I did, I eliminate the coil inside my relay. I took the coil out, so basically I just have 2 wires coming out of here. So when I take this out, Now I'm gonna read 12 volts on one of these wires and 0 volts on another. So let's just see. So I'm reading 12 volts on the black wire and going to be 0 volts on the red wire. Okay, the ghost voltage right there. So now, so my black wire, it's going to be my pin 85 right here. So it's going to be pin 85 right in here. So this is my black wire, and this is going to be my red wire, and it's going to be pin 86. Okay. So now I identify all of my pins on my relay. So now since I know this is my control wire, I can, for instance, if you want to go further, we can. Since I know this is going to be a control side of the, it's a ground side switch circuit, I can connect my test light to battery positive, and I'm just going to rest it in here so if I can see it. Yeah. So when I turn my key on, if I'm going to get the control ground from my computer, this is going to light. My Tesla is going to light. There you go. Good. All right. All right, I hope this is not too confusing. So basically I had my, what I had here, I eliminate, basically I just had my, so this was my control wire, and I put my test light right in here, and I connected to battery positive, and because the PCM is going to give me a ground, when I turn my key on, my test light. So this give me the, this is another way of testing my control circuit from my PCM. Okay, so now since I know, now this is another problem as well, that what we have to make sure also is that all the voltages that I've done on my control side of the relay, when I connected my voltmeter to pin 85 and 86, and I turned my key on, I had a 12 volts. I had a loaded circuit, so I was good there. I didn't have any voltage drop, so that was okay. However, when I checked my pin 30, my green wire, I did not have my circuit loaded, and there's a possible that I might have some kind of voltage drop on pin 30. So we can easily check that by I'm going to put this fuse back in, and now I know my red wire is my control. I'm going to use my test light. I'm going to connect to the battery negative now, and I can use this test light to activate my relay, because the test light does have enough current to activate the relay. It really needs only like around 200 milliamps of current to work. So so now I can check my green pin number 30, my feed from fuse number 8 from my load side, and I'm just gonna, let's see, I didn't connect my black lead to ground. Sorry. So now we're gonna check our pin 30 for a voltage drop, and we're gonna load it up to circuit, make sure we don't have any voltage drop. So now I'm going to so I have my test light connected to battery negative. I'm gonna touch the red pin, basically pin 86, and I'm checking my pin 30, which is my green wire, and I'm having a battery voltage there. So when I touch when I activate my relay, you can see the fuel pump is running, and I'm having a good voltage there. 12. I get a battery voltage, so that tells me that I do not have any voltage drop on pin 30. this is all we can do to test our relay here. Our voltage in the relay box, and I hope this wasn't too confusing. I try to make this kind of short, but I think I covered a lot of ground in a short amount of time. But I think it makes sense. I hope it makes sense. So anyway, let me turn my key off so I don't run my battery out. So one more. So I think I covered everything that I wanted to talk about. So now we know how to recognize our pins on the relay, what to look for. As we look our diagram. Now, many times you will not need the diagram. If you have something like this, you can easily identify your control and power side of the relay. Now, the guys that do this every day, they can simply just take the relay out, and they know right away, the pins on a box, they know on a fuse box, they know exactly what to look for. I don't do this every day, and for me, I think this actually helps a lot. One very important detail I want to say: if you decide to make something like this, you have to insulate these ends. Okay, do not leave these wires exposed. Okay, and the reason why is like this this green wire. Yes, the green wire is hot all the time. When you turn a key on, like for instance for the fuel pump, computer is gonna give the ground to this red wire, and if these two cross, you're gonna short the computer right away. The driver inside the computer that's supposed to turn this relay on is gonna burn, because you will short it. You're gonna send 12 volts down to the computer. You're gonna burn it. So please be very serious about it. What I did here, I found I had little connectors, and I soldered it to the end of this wire, and I put the shrink tube, and I protected it. But you gotta make sure that you're gonna have access to your connectors to check your voltage on it. So I hope you guys can see that. There you go. And the bottom, this is the way it looks. It's simply just to solder your wires on your pin on your relay. And I made other ones as well. The most common ones I made the same way. And I made myself a reminder on top of the relay. I wrote it down what wires are for what pin and which pin, so I know what to look for. But I made it identical for every single relay, so I don't get confused. So okay guys, I think this I hope this makes sense. I hope it was not too confusing. I think I covered all that I needed to cover. And again, if you decide to use this, please make sure don't leave your wires exposed. And that's it, guys. I hope this was informative. I hope somebody can benefit from it. It did help me. I've used it before. It really works. I mean, there's no question about it. And just the fact that you can energize the relay, yourself with a test light. You can crank the engine if you want to. You can turn on the fans. Any load that you're gonna work on, you can energize the relay and check your load and make sure it works. So okay, guys. I think that's all I wanted to talk about. Thank you so much for watching. Please subscribe to my channel, and see you next time.